And so, Chris, tell us about Coronium Sockets. What you said, you told me that Coronium Sockets are like Coronium game server without the game server part. So, what does that mean?
Basically what the idea was is to kind of abstract the socket server from the GS. And basically what it does is it kind of allows people to build more customized socket solutions. With the GS game server, I had taken care of a lot of the work behind the scenes as far as managing clients and games, etc. And so this kind of takes that away and just pares it down to just a socket connection.
So Chris, I don't want to interrupt you, but just for anybody who's listening who may not be familiar with sockets, can you give us like the 30-second overview of that?
Yeah. A socket is basically a connection from it's a client-server situation where in Corona you can actually the Lua socket library, and that library you can use in Corona to connect to a server. And once you do this through sockets, then you have a real-time connection both up and down. So similar to WebSockets and things like that, it's basically a way for you to have high-speed transfer between your client and server, and in our case that would be our Corona client. So the thing with the Coronium GS, it had a lot of hand-holding being taken care of in the background. There may be situations where you want to have a different type of configuration. It may not even be a game. And in those cases, I've put together Coronium Sockets, which again just takes that library out of the GS and kind of puts it into its own. With that, though, of course, you have to handle more of it yourself as far as building the framework. You could use this for, if you wanted to use it for a business app, if you wanted to use it for real-time analytics, things like that. Any kind of real-time or near real-time functionality. This also too is the Coronium Sockets provides a good way to kind of build a global connection. So where in the game server you would be siphoned off into different games. Here, everybody is just all connected together on the server, so it opens up different possibilities like global chat and multiplayer, bigger worlds where everybody is kind of involved at the same time, as opposed to little separate games. So what I wanted to do is just kind of show just quickly the connection and how it all works, and then just talk a little bit about how you expand it. This becomes one of the major questions, is how do you expand these things and build your own code base on top of it. So I just want to show a little bit of how that works. And I'm going to go ahead and just switch over to my screen share here.
Now, is Coronium Sockets, is that on a whole separate website, or is that someplace different? I mean, the same as Coronium Game Server?
Yeah, I don't have, the site will be up within the next couple days. So there is no site at the moment where you can get this. There is a code base, but I'm finishing up the documentation, and then I'll have a place where you can download this. So I can give you a placeholder URL at least for now.
Okay, so basically, if you're watching this live today or within the next few days, then you're getting a sneak preview.
Yeah, it'll probably be coronium.io/sockets. Probably that makes the most sense. There is no install or anything yet for this. Again, I'll have that all prepared, but this it's all ready to go and it's been tested. And I've been actually doing a lot of tests on the engine, which again, this is the same engine that the GS runs on. And I've been getting some pretty good results, so I'm going to keep doing those tests and keep hammering at it. And the most recent test, I was on a 256 megabyte box and 1,000 concurrent connections, all sending messages back and forth every 50 milliseconds. And it was about 75 was the server load, which is definitely pushing it. but at a 256 megabyte box, it's pretty impressive that you can get that many concurrent connections shooting that much data together. So next step is to throw it on some bigger boxes and do some larger tests. So again, just like GS, this has a server and a client component. The client component is for Corona. So there's just a basic project here that I have. And it's all event-driven. It's very similar to GS. So if you've used GS, then you'd be familiar with some of these. It's all just based on events, and you listen for these and take action appropriately. The server is also very simple. It's just a handful of modules, and then there is a very similar looking main for the server. So it helps to kind of quicken your development because you're kind of dealing with the same kind of actions on each side, which is common with sockets. So I've already set up a server. I put it on, I think this one's on DigitalOcean. And we can look at just logging in. I have the IP address here is pointing to it. The Coronium Sockets runs on 8100. So we'll just go ahead and see if we have anything here. Actually, I need to open up my log. Okay, so as you can see here, this is some previous logging here. The server's running, and it's gone ahead and made its connection. And here's my ping coming back. And the ping is actually an event. So here I'm just putting some output here. The ping brings back the round trip timestamp. And so I'm just printing that out here as it comes back in. This is an event that is part of the client, as are these datas, connect, ready, etc. And these are just kind of the most common events. A socket itself is actually quite a simple beast as far as what its functionality is, but when you get into the little intricacies of it is where it becomes a little more complicated. But you don't really need to worry about that stuff that much until you start getting into massive amounts of clients, etc. So on the server side, we basically have a bunch of different events here. One of the ones that's kind of important is the client connect, and from here you get the client object, and you can start to manipulate that if you want to. Client data is where we bring in our data, and this can be sent up from the client. So on the client side, there's a on client ready event, which means that everything is all hand shook and taken care of. That's the other thing, is that the server itself does still handle a couple things. It handles the handshake between the client, and it also makes sure that the client's ready, and then gives you a message, the client ready message, letting you know that you can start to talk back and forth with the server. So what I'm going to do is on the client ready, basically once I log in, I'm going to get this client ready event here, and I'm going to go ahead and just, if I want to send data back to the server, it's extremely simple. In this case, I'm going to use client. Up here I pulled in the client module for this Coronium Sockets, and I've given it the name of client. And then here I'm going to use the method client send, and it always takes a table. So, and you can send any values as you need to. They just need to be able to be JSON encodable. So here I'm going to send up this message as soon as we log in. On the server side, I'm going to go ahead and we're going to get this on the on-client data event because I'm sending data to the server. Go ahead and just uncomment out this data thing here, and this will echo out whatever data is coming up into my console window. But I will need to make sure that I upload my server file, so I'm going to go ahead and do that now. And additionally, I have to restart the server, or the process, the Coronium Sockets process. So it tells me Coronium Sockets started. I just restarted, and then I'm going to run this, and hopefully when we get the onReady event, we should get some data up here. And yeah, we got the greeting equals hello. So just right there alone is shows very simply how you can start to talk back and forth to a server. On the main Lua here, I have this data coming here. If I just decided I wanted to send something back when I get data, what you get passed on the client data is the actual client reference as well as the data, which we just saw. So if I just wanted to echo this back to make a simple echo server, I can just do, again up here, client send, and I'm just going to push that data right back down. I'll go ahead and push this back up to the server, and we do have to do refresh. Start this thing here, and we got the greeting hello here, and if you notice down here in my client now, I also have greeting hello. So that was a round-trip echo from the Coronium socket server. So now I have pretty much everything I need to, at this point, create an application using sockets. And there can be many, many clients connected. This is just obviously an example with one client. But anytime a client sends data, they're going to get back that data, but only that specific client. So it handles all of the client objects for you. One of the other things that is built in to the server itself is broadcast. So let's say somebody did want to broadcast, this would be good for chat or something like that. You can use the sockets broadcast data, and that's going to broadcast this data to every client that's connected to the server. So that can be helpful as well. There's a few other things where you can get the client count, you can get the array of clients and iterate over them and do specific things if you want to. The client object also is where you can add in, you can basically extend this to add in your own functionality. And you would most likely do that on the client connect. As soon as they connect, you could add any type of functionality you wanted. So you could just add it right to it. So just whatever, do new username. And then you could just do equals function, blah, blah, blah. And then you would have that function available on that client anywhere where you can get a client reference. So the one other thing that's important is how you actually extend the server. And when we're in the server part, we're not in Corona anymore, but we are in Lua. But there's a few different things you have to do to kind of work with the server because it's event-driven. And this is what gives it the ability to handle a lot of concurrent clients and be able to service them all. And this is something that's part of Loveit, which is the engine it runs on. And Loveit is built from LuaJIT and libuv, which is a C event loop. So it's extremely quick. It's used in very high-profile applications, and so it's at the C level. So it's, again, very, very fast. But you do need to make sure that you don't do anything that's blocking. And a blocking function or something where maybe you're reading data directly, things like that are going to block this loop. So what you have to use is events. And by using the event emitters, you can basically do all sorts of neat things without blocking that loop. And that's what becomes really important when you're building these socket applications. So for instance, let's look at extending it. A lot of times I like to, in here you're going to get a lot of different action if you're sending a lot of different data calls to your server. For instance, the way to really handle this is basically you're sending messages from the client up to the server, but you're going to need a way to kind of like know which ones are which. So in this case, if I wanted to send this, I'm sending greeting equals hello. Well, this greeting key here gives me the perfect opportunity to be able to kind of abstract what I need from this data and see what's going on. So I could do, oops, let me see, if data.greeting, and then I know that I have a greeting, so I could start to do whatever I wanted here. And so this can, depending on the complexity of your application and what type of things you're sending back and forth, this can get quite lengthy. So what I like to do is to kind of create another data handler class for it. So, and this again is an example of how you kind of extend this. So I'm going to create a new file, and I'll call this the data handler. Save this. This would go in your modules folder for your server. And And so this is specific to the server side. Everything we do, we use an emitter. And basically we extend this, this emitter object, which allows us to send and listen for events on the server. And then we can build in code appropriately. So again, this will be more documented. I'm just kind of going through it quick here. But I'm going to create my data handler class. It's basically just going to be extending this emitter. So I'm going to do that. And return data handler. And then I'm going to need an initialization function. So I'm going to do handler initialize. I'm not going to really use that now. And then I want to create an extra method that's going to consume my data. So data handler, and we'll just call it handle for easiness. I'll take in a data table that we get up. And then just for testing, I'm just going to print out this data when it hits there. So I've built this. This is the most basic form of an object that you use to add to the server based off of the emitter. Over here in my server now, I'm going to go ahead and let's go ahead and pull in this data handler. And we will just go ahead and create it here. We're only using kind of a singleton on this one, so just initialize it right here in line. So now I have my data handler, and I want to do something like handle to pass it data. Actually, I like to take the client too, because in case you need to send something back on the client, you can do that. So I'm just going to go ahead and change this. So I have a client reference if I need to. So if I wanted to send this back, this again is just basically an echo. And I'm going to send that back down to the client. And with that, I'll just get rid of that echo. So now we're saying, okay, if there's a greeting on this incoming data, send it off to the data handler and also pass the client and the data. I could just pass the greeting if I want to. And then we should see that echoed out here, and then it should also send it back. So this is a way of kind of abstracting that from here. So let's go ahead and make sure everything's back up. Oops. This is all on the main. And then we need to up our data handler. And reset the server. Okay, so let's see. We should get our greeting here and our greeting here, so that worked. So let's say the way you kind of use this main is kind of like a controller of sorts. Let's say I'm going to have a game class. And I'm going to do the same thing I did with my data handler. I'm going to create a new file, and this will be my game class. And we'll save that up. And in here, same thing. We're going to go with we're going to extend this emitter. And we'll do a game. And that. Game. And we'll look at how you work with events. So I need to also make sure I put my initialization function here. Okay, so we have that all set up. I'm pulling that in here, and I'm initializing it there. We're just using it as a singleton. This is kind of like a general game handler. We could call it that. And so basically, what I'm going to do here is we're going to send this data to the data handler, and we're going to then create. Before that, we're going to create an event to listen for. This will be a data handler on. And we're going to call this one score. We're going to pass a score back. So do that, and so that we've built this kind. This is an event listener. This is based from the emitter class, and on. Basically, it's going to listen when it receives a score event. It's going to then run this function, and that's going to be also passed a score. And then we can just pass that to the game if we wanted to update score. So this file becomes more of kind of kind of a traffic cop of sorts, but we're still spinning this stuff out to these separate classes. So we get the greeting, the data handler gets called, and then we've also have this event that we're listening for, and when we get that back, we're going to update the game score. So let's go ahead and add our game function. Let's put that. Update score, yes, okay. So now in the data handler, what we have to do is we're going to look for a score variable. So we'll say if data table score, and we're going to send this up in a second. Then we're going to send an event out. So that's because this is an emitter object, I can use self, and it's emit, and I'm going to use the score event, and then I'm also going to pass the score value. So data table score. So this is just kind of a contrived example to show how to use emitters and events. So basically what's happening here is I'm going to actually take this greeting thing out. We're not going to use that. What's happening here basically is data is coming in from the client, which we'll send up in a second. This is going to handle the data, this data handler. It's going to be looking for the score key, and if it finds it, it's going to say, okay, I found a score key, let's go ahead and emit the score, and here is the value of that. And then back here in my kind of controller here, when that happens, then it's going to call the game update score. And what's nice about these events is that game doesn't need to have any idea about the data handler itself. It could be anything. The update score method is completely on its own. And then, of course, you can add other things here, too. If you had other objects, let's say you had a UI object or something that you wanted to update, you can just add that there. And then every time you get this score event, you can update all of the different objects that you need to based on that score. So that's kind of handy that way. So we got all that in place. So on our main client, this is, again, back on our Corona here. I'm going to go ahead and we're going to send it on the client ready. We're going to send the score up. 1,000. And then again, once that goes up, that should get the client data. We're going to pass it to the handler. Handler is going to call an event. It's the score event. The game update is going to run, and then hopefully we should get this output. So let's update this here. All right, save my game at. Oh, okay, well. Go ahead and throw that up there. My game's over here. And then let's throw the main up. Reset that. And then let's run our client, see what we get. Okay, so we did. We got our 1,000. So it made that trip, and it called those events, and got back to the main Lua here. And this is basically all you need to create an application using the sockets. So now that you have everything all connected and whatnot, you can use the emitter events and kind of create your code base as far as how you want to deal with it. And again, we need to rely as much as possible on these events because that helps keep the server running fast and keep it non-blocking. So I'll definitely go over more of this stuff over time and create some tutorials. But this Coronium Sockets is kind of neat because you can create pretty much whatever you want in the socket land. In this case, we could have a big multi-user game or whatnot. So that gives you a little taste of the Coronium Sockets.
That's awesome. So, Ed, do you have any thoughts or comments there?
I do have a small question.
Mm-hmm.
When you say sockets, your sockets are UDP or TCP sockets? I'm going to guess UDP.
Yes, TCP.
Oh, TCP, really?
Yes, TCP.
Oh, excellent.
I'm not trying to hit like real-time stuff. I'm doing near real-time, and the thing is with UDP, there's no trackability. They just throw
no reliability.
Yeah, throws data out
Goes
there.
Right in the name, unreliable.
There you go. Yeah, they're just throwing out data, and you're getting it sometimes and sometimes not. So I like the TCP just because you can count on it getting there.
Not just that, but you can get the ordering is important.
Of course, yeah, absolutely. Yeah. And with turn-based kind of stuff, obviously that's like critical. So.
Right. Or if you want to move part of your game logic to the server code, it needs to be getting the inputs in correct order. Otherwise, you're hosed.
No, it's neat. There's a couple people making some games on GS, and I've been invited to test one of them, and it's cool. It's working really good, so it's pretty neat stuff.
So yeah, I'm even more impressed now. 1,000 connections with UDP, I can see that, but 1,000 connections with TCP is a whole nother,
It's this libuv. It's the C library that it's kind of the Node uses it as well. It's event driven. It's neat stuff.
It's cool. Awesome.
Yeah, they used to have the C10K problem. Now it's the C1024K problem. It's can you get up to 1 million connections? And I guess people are doing it. So.
Wow.
It was like 40 gigabyte servers. But
yeah, I wish I had that problem. 1 million connections on my game. Oh, it's such a problem.
Okay, let me ask you a couple of questions. One is, why do you choose Lua for all of your stuff? Right? I mean, you've got Coronium IO, Coronium Game Server, and now Coronium Sockets. So what's besides the simplicity maybe of Lua, like it's easy to work with. What are your thoughts there? What's your choice for Lua?
Well, definitely the simplicity, but secondarily is these tools I'm trying to create to kind of work with Corona. So my idea is, and this is how it was when I worked with Flash, is that I like to not have to have two different styles of code on the server and the client. I can move much faster. I don't know I'm sure you've done multi-language development. It's like you're in JavaScript, you're hitting the wrong buttons, you're hitting the wrong, you're not doing what you're not.
Brain malfunctions over time.
Yeah. So that was one of the things is I think people using Corona, they're investing in Lua. And so I think that helps. And additionally, it's just I did a lot of PHP server work, and Lua is just much more fun and easy and simple, and the libraries that are available are pretty cool. There's a lot of good stuff out there. And it's shown, especially LuaJIT, to be extremely fast.
Yeah, I like Lua because it's got all the fundamentals, but it's clearly missing some of the more advanced features of other languages. But you know what? I don't really miss them that much for the fact that it's so easy to use.
Yeah, it just the learning curve is slight, and then it's for me, I understand that there's not like any typing or anything like that, but for me it's like that's my responsibility. I make sure that my code does what it's supposed to do. I don't need to constantly go through.
I think the speed comes out of that, right? Because you're not relying on something where it's executing a lot of code to do a little check that you should have done in the first place.
Exactly. Yeah, I think it gives the programmer more responsibility personally. But, yeah.
No, okay, so the other question I had was, I haven't spent a lot of time working with sockets personally, but there may be some people who are interested in the concept, especially since you've gone to such lengths to make it approachable. Especially when everything we just saw is very human readable code. It was easy to follow, even if you didn't 100% understand what sockets could do for you. Is there a primer out there that you recommend that would help people with the concepts of sockets, or is it is there nothing like that?
There's obviously varying degrees of information out there about sockets. Again, I think that a lot of times people maybe make sockets out to be some type of weird, mysterious thing that's hard to handle, and it's some special science, but it's not really. It's the same thing as basically. You're using sockets in your web browser. It's just they're not staying connected. They're just hidden and then coming back. And in this case, we're talking about sockets that are keeping a consistent connection, so a persistent connection. So it's just the data. It's just a data pipe. It's the same pipe you're using for anything that's happening in your computer when it's leaving your network.